Hello and welcome back to another video. So today I wanted to go through a rather fun geometrical problem here. So the problem asks us that if we have an inverted cone of height h, and if I fill it only half of the way up, so let's say that's h on 2, then what percentage of the total volume will we have actually filled up for this cone? So the first things first that we quickly need to make sure we understand and can define very clearly is the volume of the cone. So let's say the volume of the large cone, so the total cone, we'll say is equal to, well, pi r squared h over 3. Okay, so that's just our general volume of a cone formula there. Okay, so now let's start thinking about, well, what happens for the smaller cone? Well, again, we'll have that formula, V equals pi r squared h over 3, except the only difference now is that, well, we have a different height. So what we can do is we can quickly put that in as h on 2. But what about our r squared? So clearly the radius will not remain the same. It will in fact decrease. So what we need to figure out is what will our new radius become? Alright, so to have a bit more of a proper look at that problem, I've gone ahead and drawn a cross-sectional area of this situation for us. So we've got two different triangles here. So we've got triangle ABC and triangle ADE. So these are just cross-sectional areas of that larger cone where we can see this is going to be our height h, and this section here is h on 2. Or we might be better off, in fact, writing that now as AD equals h and AB equals h on 2. Okay, so what's going to be very useful for us now is if we quickly identify what the relationship between these two triangles actually is. So we've got, let's quickly look, so we've got triangle ABC and we've got triangle ADE. Alright, so what is the relationship here? So they both share a common angle, and that is the angle subtended from this point A over here. So we can clearly see that they both share that angle. And now they both have right angles as well, and that therefore means that this angle here is equal to this angle here as well. So in fact, just going off of the angle, we have a similar triangle proof. So just off of that, we can say that these two triangles are in fact similar. Now, to then use that to figure out the length BC, that new radius, what we need to do is we need to start looking at, well, what exactly is the scale factor here? So if we've essentially gone from AD down to our smaller triangle here, AB, and we've cut it in half, well, you guessed it, that's exactly what we're going to do for the ratio of DE and BC. So we'll quickly write that up. So DE, we can quickly write that as R, and BC is, again, simply just going to be R on 2. Okay, so now that we have a new radius in terms of the old radius, we can go ahead and put that in to our formula that we had above. So now the smaller cone, I might describe this as V sub s for the smaller cone, is going to be written out as pi. So the radius now is R over 2, that's all squared, times by the height, so that's length AB, which is h on 2. And again, that's all over 3. All right. So what about our volume of the larger cone? That was V sub L, and that was simply equal to pi r squared h over 3. All right. So what we want to do now is we want to figure out, well, what is the difference between the VS and the VL? Well, clearly the only actual difference here is that we've got, well, r over 2 squared, that means we'll be introducing a factor of 1/4 there, and then h over 2, that's a half, so that'll become 1/8. So putting VS over VL, what we end up seeing is that we'll have a total of 1/8 of the larger volume of this larger cone is actually filled up with V sub S. And so if we wanted to write that out as a percentage, that is going to be 12.5%. And there you have it. So for whatever cone you might have, if you fill it up only to halfway, then you'll only be filling it up to 12.5% capacity. And there we have it. So if you have enjoyed this video, please leave a like, subscribe, comment. Let me know if you'd have any other problems that you want me to go through, and I'd love to have a look at them. and I'll see you next time. As always, stay curious.